Hello, can you hear me? Hello, can you hear me?
Yeah, I can hear you.
Yeah, I was having problem logging in earlier. That's what's delay. The cause of the delay. Logging in was I was having a tech problem, but now I'm glad I'm able to get in. So today let me show you what we need. We'll be covered what is required of you this week. I'm going to a class. I'm going to share this with you. So this is, if you look at my announcement, this is week 7, of course. Oh, it's 7 right here. So you can see the requirement. We are now, we're going to start reading chapter 5. But we'll finish chapter 4, first of all, before we begin that. So we'll finish chapter 4 and then begin chapter 5. For the assignment, there are 3 assignments that are due this week. Classwork 7, which I will make available after the class is over today. Then homework 6. I'm going to I'm going to extend the due date for homework 6 to next week. Then complete Excel assignment number 5. And I'm sure that you already know that you can access this. You can have access to this by going to the models and scrolling down to week 7 to 8. So this is where you're going to access all this. Having said that, let me make Excel assignment available. So having said that, we can now begin. So last time we stopped at counting rules. We finished the probability theory. Now let's begin with counting rules. We also use some of these counting rules in solving probability problems. We have the fundamental counting rule. We have the permutation and then combination. Okay. So the fundamental counting rule, let's start with that one. The fundamental counting rule says in a sequence of n events in which the first one has k1 possibilities, and the first two, the first one have k1 possibilities. The first one have k1 possibilities. My mistake. The second one have k2 possibilities, and the third one has k3 possibilities, and so on like that. In such a sequence of events, we will have that the total number of possibilities will be k1 times k2 times k3 times kn. I mean, all the way to the number of possibilities we have, multiply them. That is what it's saying. K1 multiplied by k2 to k3, all the way to the last possibilities. Let's see how this works. Look at this question here. It says a coin is tossed and the dice is rolled. Find the number of outcomes in the sequence of events. Okay. Find the number of outcomes in the sequence of events. Now, for the coin, we know that a coin have 2 sides. So k1 is 2, and the dice have 6 sides. So k2 is 6. So that the number of possibilities will be k1 times k2, okay, which will give us the number of possibilities in that sequence of events. Excuse me, sorry. Number of possibilities in that sequence of events. So with that, we can have our k1 and k2. K1 and then k2 can be, you have it in this form. So on k1 is 2. That'll be 2 times 6. That gives us 12 possibilities. A number of outcomes, 12 outcomes, 12 outcomes. That's what it means. Any question on this? Yeah, no, that's good because this one is simple. And let's look at another example. You can ask the question in different form. Look at it. It says, a paint manufacturer wishes to make several different paints. The categories are as follows. Color can be red color, blue, white, black, green, brown, yellow. Type can be latex or oil. Texture can be flat, semi-gloss, high gloss. And use, it can be outdoor, indoor, or indoor, outdoor or indoor. See how many different kind of paints can be made. A person can select one color, one type, one texture, and one use. So let us get our Ks, K1, K2, K2. So our K1 will be color. How many colors? Have one, red, blue, white, black, green, brown. So how many of them? 1, 2, 3, 4, 5, 6, 7. K1 is 7. 7 colors. K2 is the type. There are 2 types, latex and oil, so 2. Then K3 is the texture, flat, semi-gloss, high gloss. So it's 3 of them. And then K4 is used, can be used indoor or outdoors too. So number of different kind of paints now becomes K1 times K2 times K3 times K4. And that will give us the number of different kind of paint that is possible. So we can, make the adjustments here. So this has K sub 3, K sub 2, K sub 1, and so on and so forth. Okay. So that gives us K1 is 7. That be 7 times 2 times 3 times 2. So write this down so that I can get it from the calculator. Got 7 times 2 times 3 times 2. So using our calculator, Desmos calculator. I have it somewhere. I know I opened it. Okay. Yep, it's right here. So using this, we can get our answer. We have 7 times 2 times 3 times 2 give us 84. 84 different kind of paints. 84 different kind of paints. Equals 84 different kind of paints. See, that's how you solve this. Get your K1, K2, and K3, and then you simplify it. Yep. Now look at a tricky one, and I'm going to move it down so we can have enough room for it. A trick says the digits 0, 1, 2, 3, and 4 are to be used in a 4-digit ID card. How many different cards are possible if A, repetitions are permitted, B, repetitions are not permitted, C, repetitions are permitted, but the first digit cannot be 0 or 1. So remember, this is a 4-digit ID card. And you're going to choose from these 5 numbers. So you have 4 slots. Can be, this is the first slot, the second slot, third slot, no, fourth slot. Okay? 4-digit ID card. Now, you say repetitions are permitted. And we have this number to choose from 0, 1, 2, 3, 4, 5 numbers. Now, 0, if you say repetitions are permitted, I mean, if 0 is used here, it can also be used in any slot, in any order. Same thing with 1, 2, 3. Any of these numbers can be used in any of these slots. in any order. So because of what? Because it says that here that repetitions are permitted. So in that case, number of cards will be number of cards will be, there are 5 numbers to choose from, and there are 5 numbers with 4 slots. That'll be 5 times 5 times 5 times 5. Because any of this number can be used in any order in each of the slots. So that gives us 5 times 5 times 5 times 5. 625. 625 cards. 625 cards. Now, that's for the A. Part B says repetitions are not permitted. In that case, here you have 5 numbers to choose to be used to make a 4-digit ID card. Now, because it says that repetitions are not permitted, it means that if you use 0 on this slot, you can never use 0 on this slot anymore. But you can use it on this one. Whatever. If you use 1 in any of the slots, once you use a number in a slot, you cannot reuse that number in that slot again. So that means there's a restriction. So the number of slots that you use each number is decreasing. So in that case, number of cards will be number of cards it equals 5 times 4 times 3 times 2. Because there are 4 digits. So it's about 2. I mean 4 slots, it's about 2. 5 times 4 is 20. 20 times 3 is 60. And then 60 times 2 is 120 cards. Cards can be made. Okay. Now, part C says repetitions are permitted. Okay. But the first 2 digits cannot be 0 and 1. So remember there are 4 slots. But the first 2 digits of that card, that means this one and this one, cannot be 0 and 1. So there is restriction on the numbers 0 and 1. So if you remove 0 and 1 from the list of 5 numbers, the only thing that we left is 3. So for the first digits, you have only 3 available. But the rest of the digits, the rest of the slot, like this slot and this one, we can use any of these numbers, 0 or 1, 2, 3, 4, in any order. So that means for the first two digits, first 2 slots, there's a restriction. But the remaining slots, there's none. Equals to now first, you say 2 numbers cannot be used on the first slot. So that means what is left for the first slot is 3 numbers. So to choose from. So you have 3, but the remaining slots can use any of the numbers. 5 of them. 3 times 5 times 5 times 5. So that it was 3 times 5 times 5 times 5. 375 cards. 375 cards. Okay. 375. And be merged. So any question on this one? Any question?
No.
Good, excellent. Now let's look at permutation and combination. Permutation simply means the arrangement of an object in a specific order. And this is the formula we use to find the permutation. I mean, if you want to do it manually, use the formula here. N permutation x equals n factorial divided by n minus x factorial. Combination is arrangement of object in any order. In any order. So there's no specific order. So this why permutation have a specific order, combination can be in any order. And this is the formula here. N combination x equals n factorial divided by x factorial times n minus x factorial. So if you want to do this calculations manually, that's when you use this formula. And you hear me to say factorial. What do I mean by factorial? You know that in English language, we call this symbol here. We call it in English language, we call it exclamation mark. What about this one? But in statistics, we call it factorial. For example, 5 factorial means 5 times 4 times 3 times 2 times 1, which we can get from the calculator. 5 factorial, 5 times 3, 4 times 3 times 2 times 1, which is 120. So 5 factorial is 120. Then 8 factorial, for example, is going to be 8 times 7 times 6 times 5 times 4. Okay. 5, so 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So you can go and put it here. So we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 40,320. 40,320. Okay. So that's when I say n times npx equals n factorial over n minus s factorial. So you can now begin to get the picture of what I mean by that. So now let's see. But for this class, we'll be using calculator to get it. We're going to be using calculator the calculator to find the permutation and the combination, not the formula. But you can, if you like, you can practice how to use the formula. That is still good. So I wanted to show you this. So let's see how I can do this. Now I have, you say evaluate this. So let's start with the first one. First one is A, but A says NP3, that is 12 permutation 3. 12 permutation 3. And make it big. I'll make it 18. 20. So in this case, we have that our n here. Our n here is 12. I'll make it 18. It should be better. Our n here equals 12. And our x equals 3. So that 12 permutation 3 now becomes equals to. So we go to our calculator to get it. I mean, like I say, you can use the formula, but for this class, since you're not you'll be using a calculator to get it, to save time, save you guys time. So you have NP 12 permutation 3 now becomes, you go to the calculator. So clear this, then go to the function section and just see the NPR right here. That's the permutation. So click on it. It pops out. Just try 12, 3. Give me 1,320. So 1,320 is the answer. Okay. 1,000. Okay. 320. See? That's what it means. Now, if we want to compare this to combination, we're supposed to have 12 combination 3, for example. This one is different because it's combination. In that case, answer will be different because that they have different set of rules. So this one comes to say, in that case, when you go to the calculator, in this case, the same n is 12 and s is 3. When we go to the calculator, we're gonna have this. We're gonna click and choose NCR. Click on it. Then 12, comma 3. Give us 220. 220. Okay. 220. So we have 220 right here. If it's combination. But if its permutation is 1,320. So that's how you can get this stuffs. 12 permutation 3 is just 12, comma 3. And but make sure that you click on the permutation key. For combination, you click on the combination key. Get the result. Let's see the application here. It says here, so that a TV news director, wishes to use 3 news stories on an evening show. One story will be the local lead story. One will be the second story. And the last will be the closing story. You can see that there's a specific order. Local lead story, second story, and the closing story. See, there's a specific order, which means that's what you can use as permutation. He said, if the director had a total of 8 stories to choose from, how many ways can the program be set up? So here we have 8 stories to choose from. So our N is 8. Our X has 3 story. Have one is gonna be a lead story. The other one will be the second story, and the last one will be the closing story. So that's 3 types of stories. So X is 3. So the number of possible ways. So number of ways now become number of ways become 8 combination 3. Okay. Can go back. 8 combination 3. Okay. Now, sorry, not combination, my mistake. Sorry. Permutation, not combination. Permutation. Because it says there's a specific order. 8 permutation 3. So we go to our calculator and then choose to comma, click on the permutation key. 8, comma 3. It was 336 ways. 336 ways. So that's 6 ways. Can choose. So, any question on this, guys? Any question?
I do. How do you do this on Excel?
Excel. I still have a different. Actually, I haven't really done it in Excel. I normally use calculator for that, but I'm gonna make it. Huh? Hello?
Oh, okay.
Yeah. Usually I do it in a calculator. I'm sure Excel must have a formula for it. Let's see. Let's see. Let's see. That is a good question. Excel formula. Let's see. This is. Let's share this first. Okay. Excel formula. Excel formula for permutation and combination. So so now look at that. What I said. It gives us can you see the screen? Hello.
Yes.
It says permutate, then returns. So now let's say that we have Excel. See the formula. Let me write it down so you can see the formula in Excel. Number chosen. Same says permutation. Let's say make it number okay. It's permutation. Permutation permutation A. Permutation A, okay. Number, comma, number chosen. Chosen. So that's what it says. So let's see. Let me open Excel. Let's try it in Excel, right? Yeah. To do this in Excel, I'm gonna make all of this. Make it this place. I'm gonna use this place. I'm gonna make it 14 or 16. Okay. Now let's say we have n equals x equals I don't know if you can see this. Okay. What we have, or is n is 8 and x is 3, right? So for Excel, n is 8, x is 3. So the permutation, okay? Permutation now become permutation. Okay, it become equals excuse me, let me use uppercase. Okay. See, it shows up, double click on it, then click on 8, comma, then 3. Press enter key. I don't think I did it well. So let me do it the other way. Okay, 3, comma, 8. Yeah, give me 1 minute. I'm gonna figure this out. Just 1 minute. It's a good question. Excel. Where is it? What is it right here? So okay, I'm gonna open it here. MPR. Okay. Okay. Excel. Good. So say we have yeah, permutate 26. Calculate the permutation. Okay. Yeah, 3 items to choose from a set of 26. Okay. So you have permute formula. Okay, I use the wrong formula. Okay, that's why. Okay, I see. Permute. This one right here. I will click this number, comma, and then 3. See, 336. Did you see what I did, sir?
Yes, I saw.
Yeah. And also, if you want to do combination, you have equals combination, combine. See, combine, double click, number, comma, then 3, choosing 56. So, and as a verification, if you go to the calculator, say let's say we want to do combination, say NCR 8, comma 3 is 56, which is the same thing that Excel gave us here. So for Excel, 56. So for Excel, this is the formula here for permutation. Permute, you put parentheses, then click on the N, comma, and then click on the X, press the enter key. And for combination, is combine, click on it, then click on the N, comma, and then X. Good. So that's how you do it in Excel. Any other question?
No, that's it. Thank you.
You're welcome. Yeah. So now the combination, we have shown you both of them. Now let's look at this one, combination. We can verify this. Let's use the one that is more big. For that, since to make more to get this more clarified, for Excel I can type, because this is when a student asks a question, sometimes it helps me to update more information. So for Excel, let me type there for Excel. Oh, you know what? Let's do it while we are going to do the other one. So we want to do this one here. Combination X. Okay. Say evaluate this. Okay. So evaluate this using the calculator. Evaluate using the calculator. We have, well, this is 20 combination 5. So you got 20. Sorry, my calculator. Clear it. Click on the combination key, NCR 20, 5. Give me 15,504. 15,504. Now, from Excel, this is from calculator. Okay. From calculator. Okay. Now, from Excel, we can do the same thing in Excel. So let's go to Excel. I'm gonna copy this again and paste it here. So, like I said, this one give us this one is from calculator 15,504. And that is 20 combination 5. Let's do it in Excel. Let's say that we have, I want to clear this and put 20 here, combination 5. So in that case, put equal, combine. It pops out, double click on it. Then for the number, click on the N, comma, number choosing, click on the X, press the enter key. See, give me the same thing, 15,504. 15,504. So from Excel. So you get the results. 2 results here now. Now let's apply this. Look at this question. It says a bicycle shop owner has 12 mountain bicycle in the showroom. 12 mountain bicycle in the showroom. He said the owner wishes to select 5 of them to display at a bicycle show. How many different ways can the group of 5 be selected? So there's no specific order. Here we have 12 mountain bikes to choose from. So our N is 12. And you want to select 5 of them. So X is 5. So that's number of ways now become number of ways become 12 combination 5, which will give us the answer. Let me adjust this. 12 combination 5. So that means you go to calculator, 12, 5. Say click on the 12. Let me clear it. Okay, click on this 12, 5. 792 ways. 792 ways. You can do that in 792 ways. Okay. Now, this question can be asked in a different form. I mean, when I said, the question about combination can be asked in a different form, like this one here. It says, Move it down so we can have enough room. A committee, sorry, in a club, there are 7 women and 5 men. A committee of 3 women and 2 men are to be chosen. How many different possibilities? How many different possibilities are there? So men, there are 7 women and 5 men. Men, there's 5 men. Okay. 5 men and 7 women to choose from. Now, a committee will have to be 3 women. So 3 women and 2 men. Okay. Okay. Now, how many ways can be this chosen? So you can see a number of ways. Number of ways. Maybe for men, we have 5 combination 2. For women times, we have 7 combination 3. That's how many ways they can be chosen. Let's make some adjustments here. Okay. That gives us the results we're looking for. Okay, so let me write this down so we can complete the calculation. So I got 5 combination 2 times 7 combination 3. Okay. Let's go and get the result from the calculator. So we have NCR 5,2 close the parentheses times NCR again 7,3 and then close parentheses. 350 ways. 350 ways. 350 ways. Ways. Any question on this?
No.
Excellent. So now we are ready to, no, this concludes the chapter 4, which is probability. Now I'm going to close this handout so that we can begin a new top chapter, which is the chapter on probability distribution. So we have, I'm going to open it from here. The chapter on, yep, right here. I have to open it now. Well, it's, okay, I'll share it with you. So I'm going to close this Excel. So it was taking more space here. Okay. The chapter on probability distribution. Now, let's begin with the concept, basic concepts. Now, start with random variable. A random variable is any variable that have values which are determined by chance. For example, when we toss a dice, the outcome can be 1 showing up, 2 showing up, 3 showing up. All these are random. For example, if the arrival time for a bus in a at a bus stop can also be random sometimes. If the bus is supposed to arrive at 10 o'clock, it might arrive 5 minutes early, or 5 minutes late, or 10 minutes late, or even on time. So these are the value are determined by chance to some extent, depending on the traffic. Now, number of siblings that somebody might have. For us, it is random to us because we meet people at we meet people at random. So number of people, so siblings that people we meet at random is also a random variable for us. Now, that's what we call discrete random variable. They are called discrete random variable because they assume finite They are basically a finite and or infinite number of possible values that can be counted. They can be counted. So call them discrete random variable. For example, number of people jogging at Patterson Park. You can see that one person is jogging, or 2 people are jogging, or 5 people. You cannot say 1.5 person is jogging, though. So you can say that. So, how about this? Number of eggs a hen lays in 1 week. 1 egg, 2 eggs, 3 eggs, 5 eggs. But you cannot say 1.5 egg or 5.5 eggs. Can't say that. But all is that they can be counted. Things like number of calls you receive in your cell phone. 1 call, 2 calls, 0 call, you know. Now, for the continuous random variable, this one are measured. They can be measured, not counted. Things like height, temperature, voltage, and so on are measured, not blood pressure, you know. Now, for them continuous random variables. Now, tonight, we'll be looking at discrete random variable, discrete probability distribution. A discrete probability distribution consists of values that a random variable will have, values they will have, and their corresponding probability of those values. The corresponding probability of those values. The values that a random variable can have and their corresponding probabilities. That would make up a discrete probability distribution. Now let's see. We have already explained that. But as a matter of fact, let me put it this way. What I give you is the general definition of a probability distribution. The values a random variable can have and their corresponding probabilities. Now, we have 2 types. We have the discrete probability distribution, and then we have the continuous probability distributions. Now, example of discrete probability distribution include the binomial distribution and Poisson distribution. There are others. These are the ones we focus on. For this class, we focus mainly on binomial distribution. Now, for continuous, we have normal distribution and we have uniform distribution. But we focus more on the normal distribution. Okay, mainly on. But before we begin, let's look at how we can now let's solve some questions on that. The first one says, I'm gonna move this down a little bit. The first one says, construct a probability distribution for rolling a single dice. Excuse me. Drink water. Rolling a single dice. We have yes, dice have 6 sides. So to answer this question, we make a table like this one here. I'll make it bigger. Make it 16. See all the outcomes, X, and their corresponding probabilities. And they say construct a probability distribution for this outcomes. So for this, you know that for one showing, we have a dice have 6 sides. So each outcome have 1 out of 6 chances. That's the probability. For 2, it's also 1 out of 6 chances. For 3, 1 out of 6 chances. 4, 1 out of 6 chances. Okay. For 5, 1 out of 6 chances. And for 6, still 1 out of 6 chances. Okay. And you are done. It is their outcome and their corresponding probabilities that make up the probability distribution. Okay, you're done. Any question on that one? Okay, good, excellent. Now let's try another example from this type. So you see, this one is application of it as a matter of fact. You say that during the summer months, a BMZ Rentals Incorporated, a rental agency, keep track of the number of chainsaws it rents each day during a period of 90 days. Number of saws BMZ rented per day is represented by the variable X. The results are shown here. Here it says results 0 days. I mean 0 chainsaws. For 45 days, they did not rent any chainsaw. Then for 30 days, they rented one out. For 15 days, rented two. Say compute PX for each. That means say calculate the probability for each of the outcome X. Then it says construct a probability distribution and grab the data. Okay. So now let's do it. Let's do it. First of all, let's answer the first question. Say compute PX. That means the probability for each of the outcomes. So I'm gonna copy this table and put it under the solution so we can now answer the question. Okay. It says calculate the PX. Part A says calculate the PX. Okay. I'm gonna make this 16 or 18, make it 18 as a matter of fact. So let's calculate the first one is the probability of 0. So P of 0, probability of 0 become equals how many days that they didn't rent any chancellor is 45 days. That means 45 out of, well, you know what, we're gonna first of all find the total for this. Okay, write the total so we can get the total for that. Before we can, because you need the total to be able to calculate the required probabilities. It says 45 plus 30 plus 15. As a matter of fact, 15 plus 45 will give us 60 plus 30 give us 90. As a way of verifying this, I'm going to write this down: 45 plus 30 plus 15. So we got 45 plus 30 plus 15 gives us 90, which is 90. Yeah. 90 is total. So now we can now find the probabilities. So I'm gonna since I'm looking for the probabilities, I'm gonna put this here, underline for the PX. For the PX. Okay. I'll make it a little bit broader. PX. X. Okay. Now the probability of 0 will now become 45 out of 90. Because on 45 days, they didn't rent it. So out of 90, 45 over 90. Okay. 45 over 90. Which will give us what you want. So 45 divided by 90. 45 divided by 90. 0.5. So you have 0.5 here, 0.50. So we have 0.50 for 0. Now, next is the probability of 1. Okay, we have that P of 1 is going to be equals 1. We have for 30 days, the rented one chance of 30 over 90. So we're going to have 30 divided by 90. Change it to 30. Give me 0.333. I mean 0.33 rounded. 0.33 rounded. Next is the probability of 2. So you can just go here. P of 2. The rated 2 chance source. It's of 15 days. the relative chance out of 90. Requires, that means that probability that it occurs again, probably 15 over 90. Okay. 0.16666, so 0.17 basically, 0.17. 0.17. So now we have all this. Let me put them in the table. For one is 0.33. For 15 is 0.17. So we have answered part A. And part B say construct a probability distribution and then grab the data. So now let's to construct a probability distribution, we just have to rearrange it because we have the required probabilities. I'm going to just remove this one here. See, you can see the outcomes and the corresponding probabilities, and that is your probability distribution right there. Okay. Now the last one, part 3 is the last question there is, last part of the question is to grab the data. So I'm going to grab this data. To see the graph it. Let's graph it here. We can use we have x is 0, 1, 2, and this s stands for the number of chainsaws rented, x. So I'm gonna have okay, I'm gonna have here number of of chainsaws. Okay, saws rented to x. To x. Then so we have 0 chainsaw, 1 chainsaw, 2 chainsaw. So we have 0 chainsaws. Okay. 1 chainsaw, 2 chainsaws. Okay. So I can put, and for this, the other one is their probabilities. It goes from 0.17 to 0.50 to 0.50. So that means it's gonna be go from here 0.1. Okay. 0.2. Gotta go up a little bit. 0.2. 0.3. 0.4. 0.5. So I'm gonna bring it down so we have enough room. Okay. So you can make the chart. You can put the draw the diagram right here. The x-axis. And the y-axis. And the y-axis is your px. Okay. Yeah, I'm gonna px. That's your px right there. The probability of x. Okay. Right here. This is the number of chainsaws rented. Now you can make the diagram. First one is 0 chainsaws. We have 0. I'm gonna move this a little so you can have a 0. Okay. For 0, we have 0.5. So I'm gonna put top of 0.5. Be sure I'm saying this. Okay. For 0 is 0.5. I'm gonna draw the make it from 0.5. Okay, from 0 go all the way to 0.5. Okay, for 1, 1 is 0.33. See 0.3 right here. 0.33 should be around this neighborhood. So where I am. 1. Point 3 should be around here. 0.33. Yeah, probably a little bit lower. Okay, then the next one will be 2, which is 0.17. Here is 0.1 here. 1.17 should be very close to 0.2. So I'm going to put this here. Okay. So that's a graph right there. Yeah, the graph right there. Any question on this? Any question, guys, on this? So no question. So no question. Excellent. Now, at this point, we are now ready to review, look at some of the requirements, the key requirements of a probability distribution. Two requirements for a probability distribution. The first requirement that the sum of the probabilities of all the events in a sample space must equal 1. So when we look at this, saying that all the sum of all the probabilities will be equal 1, like this one here. If you add all of them, you see that you're gonna get 1. Okay, I mean add all these probabilities. So 1/6 plus 1/6 plus 1/6 plus 1/6. Okay, plus 1/6. Let me see how many of them have. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So one more. Plus 1/6. That'll give us 6/6, which give us 1. So this one is 1. 1.0. That's, and then the other one is something. If you add all these probabilities, add all of them. Okay. Here we have 0.50. Okay, 0.50 plus 0.33 plus 0.17. You go and get the calculator and calculate this. God, excuse me. 0.50 plus 0.33 plus 0.17. Let's go and add it. .50 plus 0.33 plus 0.17. See, 1, give us 1 as well. Okay, that'll give us 1.0. Okay, so that's what he's saying here. That, see, this one give us 1. This one give us also 1. That the sum of the probability, that means 1. So that's one of the requirements for becoming the to be called the probability distribution. That the sum of all the probabilities in the sample space must equal 1. Second requirement say that the probability of an event in the sample space must be between or equal to 0 and 1, which means that that a probability cannot be a negative number or a number that is greater than 1. So it means that if you are calculating probability and the answer is negative number, it's incorrect. Or the answer is bigger than 1, it's incorrect. So let us see how can you illustrate this. Look at this example. It says, determine whether each distribution is a probability distribution. You look at the numbers given. So the first need to add them, see if they add to 1. If they add to 1, let me see this. So we have sum of x, this means sum of px. I mean sum of all these probabilities. 1/5 plus 1/5 plus 1/5 plus 1/5. One of them will say 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, plus 1 over 5. That gives us 5 over 5, which is 1. So the answer is yes. Yes, okay. Because the sum of the probabilities equals 1. So that's why it is yes. So the sum of the probabilities equals 1. Now, how about this one? It says, is this a probability distribution? And this one, you don't even have to do any work because one of them is negative and one of them is bigger than 1. Because here it says that the probability of an cannot be a negative number or a number that is greater than 1. So here we have a negative number here already. Negative 1.1. They will have a number that is bigger than 1. So the answer here is no, you don't even need to do any work. Just type no, because the probability of one of the outcomes has a negative value. Negative value. The other one has a value that is greater than 1. Excuse me. Any question on this? Yeah, excellent.
No.
Good. How about this one? It says, is this a probability distribution? Again, to find out, we're gonna sum this. Add all the probabilities, all the required probabilities. So in this time, it says some of PS, I mean some of the probabilities includes 1 over 4. I made this 18. We got 1 over 4 plus we got 1 over 8 plus 1 over 16 plus 9 over 16. So let us add all this, see what it will give us. Okay. I'm writing them down. 1 over 4 plus 1 over 8 plus 1 over 16 plus 9 over 16. Going to our calculator, we're going to have this there. We got 1 over 4 plus 1 over 8. Okay. Plus 1 over 16. Plus 9 over 16. This is 1. See? Answer is 1. So the answer becomes just like the other one. All right, I have it here already. I'll say yes, because the sum of the probabilities equals 1. Says yes. How about this one? Is this a probability distribution? So to answer that, we add this. Since it doesn't have any negative numbers, so we just add what you have. So we have 0.5 plus 0.3 plus 0.4. You have 0.5 plus 0.3 plus 0.4. So let's go and get it on the calculator. Zero 0.5 plus 0.3 plus 0.4, 1.2. So it's not, because it's greater than 1.2. So the answer is no. Okay. No. Because the sum of the probabilities is greater than 1. Okay. So if it's greater than 1 or it's negative, it's not a probability distribution. But if it's equal to 1, it is. Now we can ask a question like this question in a different form. That in this case, you'll be given the outcomes and their corresponding probabilities, but one of them will be missing. How do you find it? Look at this question. It says, determine the required or missing value of B to make the distribution a discrete probability distribution. So you can see that for 0, outcome is 0.41. For 1 is 0.02. For 2 is B, which is what we are looking for. And for 3 is 0.35. So to find B, you have to make a flashback to the theory. Say that the sum of the probabilities of all events in a sample space equal 1, which means that this one here, you're supposed to, if you add them here, it's supposed to be 1. So to find B, just use 1 to subtract all of them. 1 minus 0.41, 2.41 plus 0.02 plus 2.35. That will give you your answer for B right away. Let me write this down. So I got 1 minus 0.41 plus 0.02. Okay, plus 2.35. 1 minus that. Let's go and put it on the calculator. So you got 1 minus 0.41. Is it 41 or 42? Let me see. Yeah, 41. 41, this. 0.41 plus 0.02 plus 3.35. 0.2, see, answer is 0.22. So B is 0.22. 0.22. Any question on this? Okay. Any question? Okay.
No.
Okay, no question. Good. Now, this time, we are ready to now look at the mean, variance, and standard deviation of a probability distribution. The mean, the variance, and the standard deviation of a probability distribution. For that, remember, we have done the mean, variance, and standard deviation before in the past, but we did it for a frequency distribution. This time around, we are doing it for a probability distribution, mean, variance, and standard deviation of a probability distribution. So now, this is a different formula. The mean is symbol, the same symbol, mean. Sum of x times probability of x. The sum of x times the probability of x. Variance is the sum of x squared times the probability of x minus the mean squared. And it's only the variance that the standard deviation that stays the same, which is the square root of the variance. So let's try this with an example, an application example. It says here, Davis Williams is the president of the Middle River Community Bank. Yeah, he's the president of the Middle River Community Bank. Now, Mr. Williams feels that each savings account customer has, on average, 3 credit cards. So the following, that is his claim. The following distribution represents the number of credit cards each people own. So, have no credit card. This is the probability of that. 1 credit card. This is the probability of that. You know, and so on. It's a find the mean. Let me take this. The mean, variance, and the standard deviation. And then, is Mr. Williams correct in his claim? To be able to answer this, you need to make a table like this. This is the shortcut method of finding this. And make this to be 16. Yeah. So we're gonna find, we are giving X and PS, put them in here. X for this and PS. Now we need to find X times PX, because it's part of the formula. X times PX means this one here times this one. So 0 times 0.18 is 0.00. Any real number multiplied by 0, answer is 0. Now 1 times 0.44, 0.44 is the answer. 2 times 0.27, you can verify this with the calculator. 0.50, sorry, 0.54. So I got the rest of them as 0.24. Okay, the other one, which is 4 times 0.03, I got 0.12. You can verify this with your calculator when you get the chance. Now for X squared, you have to square all this. 0 square is 0, always. 1 square is 1. Oh, excuse me, 1. Now 2 square means 2 times 2, which is 4. 3 square means 3 times 3, which is 9. Excuse me. And of course, the last one, but not the least, is 4 square, which is 4 times 4, which is 16. Okay. Now, next is to multiply that to get X squared times PS, which is part of the formula for the variance. So X squared times PS, we have our X squared here. So we need to find this X squared times PS. We're gonna do this. I'm gonna use this to do it for you. I can even use this draw. We're gonna do this one here. S squared times PX right here. Okay. S squared times PX. See? S squared multiplied. So now we have 0 times 0.18 is 0.00. 1 times 0.44 is 2.44. 4 times 0.27. I got 4 times 0.27. I got 1.08. So I got the rest of them just like that. I got 2.72. I got 0.48. So now we need this total here and this one. So you add all this. I added all this. I got this as the answer for the that side 1.34. And for if I added this one here, I got 2.72. You can always verify this with your calculator. So now the mean equals sum of X times PS. Look at X times PS. These are this one right here. 1.34 is the mean. So that means the average is 1.34. But this bank president is claiming that they have, on average, each saving accounts customer has on average 3 credit cards. But actually, what they have is, like from based on our calculations, what they have is 1.34. That means approximately 1 credit card. So that means that Mr. Williams' claim is incorrect. Now let's find the standard variance, which is sum of x squared times ps minus mean squared. So we have which is equal to, we'll make it equals here. Okay, make this 18. So sum of x squared times px is right here. See, x squared times px. That's the sum. Sure, you can see very well. Sum of x squared times ps is 2.72 minus the mean, which is 1.34. But see, minus mean square means square mean 1.34 square. So let me adjust this square. So I'm gonna write this on paper so we can go and get the answer from the calculator. 2.72 minus 1.34 squared. .72. Okay, minus 1.34. Okay, and square it. Okay, it's 1.35, 1.35, 1.34, sorry, 1.34. Squared, give me 0.924, that means 0.92. 0.92. 0.90 is the variance, 0.92. So now we got the variance, and the standard deviation will be square root of variance. So I'm going to write this variance down so we can go and get us. I can't write the formula for standard deviation here because it won't allow me. SD equals square root of variance. And our variance is 0.92. Okay. Let's go and get it from the other workbook and then post it here. So let me see. I think I have the other workbook. Okay, I'll close it. Okay. I'm going to open it now. So I'm going to open Word again. So I'm going to share that. Okay. We got the formula. So you have standard deviation. I'll make this in 18. Make it 18. Deviation equals the square root of variance. Square root of variance equal the square root of variance will be equal. That means our variance was, this is our variance. The answer we got for the variance, I'm going to show you again. Our variance is 0.92. So we're going to put right there. 0.92 equals, let's get it from the calculator. Square root of 0.92, square root of 0.92. So square root of 0.92. Okay, which is 0.95, which is 0.9591166, and so on. So rounded 0.96, which should be 0.96. 0.96. I'm gonna copy this. And then paste it into our main workbook, which is this one here. Okay. So the answer is this. So we have our mean as 1.34, which is average. Variance as 0.92. And then standard deviation is 0.96. So the second question says, is Mr. Williams correct? No, Mr. Williams is not correct. Mr. Williams is incorrect. Correct. Because the average is 1.35, means one credit card. Because on our calculations show that each saving account customers is not incorrect because, okay, our calculations here shows that each savings account customer has on average one credit card, not 3 credit cards. He's claiming 3, but that's why it's 1 credit card. Any question on this? Any question, guys? Yep. Now that's excellent. So since there's no question, I'm gonna move on to the next one. So expected value. Our next topic will be expected value. Expected value actually of a random variable actually is the theoretical average of that variable. That's what it means. Is a theoretical average of that variable. So I have enough time to finish this. Okay. So I would say that let us start from this expected value from next week. I'm closing early today. But don't go yet. Let me take your attendance, your names. See who is here, who's not here. Okay. Don't go yet. Chantel Brooks. I saw Brooks here. Green. I got Green. Washington. Eric. Okay. Who is iPhone guest? Who is that person? iPhone guest. Hello, who is iPhone guest? Whose name is that? Yeah. Voilà. Bahamas. Okay. McCoy. Right. Cool man. Okay. It's a key. I have it already. Whitney Jones. Jordan Jones. Harris. Got Harris here. Okay. All right, guys. I think I'm taking all your names. I'll see you guys next week.
All right, thank you.
You're welcome. Have a nice night.
Thank you.
Welcome.
Thank you. Have a good week.
I'll be posting the classwork in a few minutes. Okay.